Welcome back everyone. In the last video we solved remove element, and in this video we are going to solve remove duplicate from sorted array. So let's dive in. Okay, so we are given an integer array sorted in non-decreasing order, which means the elements are in increasing order. We have to remove the duplicates in place such that each unique element appears only once. The relative order of elements should be kept the same. Now consider the number of unique elements in nums to be k. After removing duplicates, return the number of unique elements k. So the first k elements of the nums should contain the unique numbers in sorted order. The remaining elements beyond index k minus 1 can be ignored. So basically we have to return the number of unique elements, and those unique elements should be at the start of the array. So let's see first example. In the first example we have three elements 1, 1 and 2, in which only two elements are unique, that is 1 and 2. So we have to return 2, but those two unique elements should be at the start of the array. In example 2, we have 1, 2, 3, 4 and 5 unique elements, and all the unique elements are at the start of the array. Now how should we approach this problem? So I'll be showing you two solutions. Now we'll start with the naive approach, and then we'll see the optimized version of that approach. So if you see the constraints, it shows that any elements in the array will be in the range of -100 to 100. Now what if we replace all the duplicates in the array with 101, which means the duplicate has the higher value than all the other elements. Now we count how many elements have we replaced. For example, if you replace 5 elements, which means if the total length is 10 and you replaced 5 elements, then 5 elements are unique. The first problem is we have to return count of those unique elements. So I'll return 5. But it is also asked that we have to replace them in place, which you can also get by seeing that the nums is passed by reference. So we have to put those 5 elements at the start of that array. So now we will sort the array. So both the cases is solved. But this solution has higher complexity. We can solve this solution in big O of n in a single pass. But the naive approach is to place the duplicates with 101, which is larger than all the elements, and then at last we'll sort that array. And now while replacing that duplicate with 101, we'll count how many elements we have replaced. Now length of array minus how many elements we replaced will give us the unique count of elements. So first let's write code for this algorithm, and then later we'll understand the better approach to solve this problem. So first we'll initialize count as 0. This will give us how many elements or duplicate elements we have replaced with 101. So we'll also take size of this vector. Now we'll see for int I is 0, I is less than size I plus plus. Now if num set I is equals to num set I plus 1, this means that this element at num set I is duplicate. I is duplicate, and we'll initialize it with 101. And we also increase count by 1. And now finally we have how many duplicates we have been replaced, and we can return the size minus the count. But we have to also place all those unique elements at the start. So we'll sort this array. Okay, and now we'll see if this works or not. Okay, so our initial test case has been passed. Now we will submit to check whether this approach can pass all the test case or not. And all the test case has been passed. But this approach does not have better time complexity. So what we will do is we'll see another approach. So next approach is we'll try to solve this question in a single pass. Okay, let me explain you that approach by solving one of the example. Let's say we have 1, 2, 3, 4, 4, 5 and 6. Okay, so what do we do is we'll use two pointer approach, which means we will have two variables. First is assigned with 0 and z is with 1. Now what this ith position element tell us? Ith position element will tell us that all the elements at position I and before that are unique and in sorted order, and j will give as the next unique element. Okay, so initially I and j are here. Now at I and j, these two elements are unique. Then what we will do is, unique means they are different, so we'll replace I plus 1th position element with jth position element. But here I plus 1th element is same as jth position element. Okay, we will swap that, and after swapping we will increment both I and j. So in the next run, I will be this and j will be this. Here also both I and j are unique elements, so we'll move I and j forward. So next time I will be this and j will be this. Now also I and j are unique, so we'll move both I and j to next position, right? Now I and j are not unique, and what does I define? I says that all the elements at ith position and before it are unique and in sorted order, while j says that I will find you the next unique element. But since I and j are same, which means j is not unique element, so j have to move forward to find the next unique element, right? So j will move one step ahead, so j will be now here. Now we see I and j are not same, which means the element at position j is unique. Element at position I is also unique. So you see why we replaced element with I plus 1 and j. So here also we will replace the element with position I plus 1 and j. So here it will be 5 and here it will be 4, and now we will move I and j one step ahead. So I will be this and j will be this, right? Now Now here we see I and j are still unique, which means the element at position j is a unique element and we have to add it to our list. And at the position I is also a unique element, so we have to replace element with I plus 1 position with j. So we'll replace this 4 with 6 and here it becomes 4. And now we will move forward I and j. So I will be here and j will be out of bounds, and we will end this loop. And finally we will return I plus 1. I plus 1, what does I tell? I tell us that element at ith position and all the elements before it are unique and in sorted order. But since it's zero based index, we have to return the total unique element, that will be I plus 1. So I will be here and the unique element are 1, 2, 3, 4, 5 and 6. These two 4, that is one this one and one this one, this 4 has been taken at end. Now we'll see a slightly more complex example. Here in this example we have only single element duplicate. Now we'll see an example where multiple elements can be duplicated. So let's see example 2 of this problem, that is 0, 0 and triple 1, double 2, 3, 3 and 4. Okay, so let's assign I as 0 and j as 1. So initially I is here and j is here. J gives us the next unique element, but you see I gives as unique element up until position I and all the element before it. So these are the unique elements up until now. So you see I and j are not equal. I mean the element at I and j are not equal, which means the element at jth position is not unique element. So we'll move j one step ahead. So j is here now. Now we see the elements at I and j are not equal. We know that element at position I is unique, and we also know that at current situation the element at j is also unique, which means we have to swap element at I plus 1 with j. So this element will become 1 and this element will become 0, right? And now we move I next position and j to the next position. Okay. So at this position I is at 1, this element, and j is at this position. Now are the elements at I and j equal? Yes, they are equal, which means the element at position j is not unique. We have to move j one step ahead. Now, are the elements at I and j same? They are same, which means the element at jth position is not unique. We have to move forward one step ahead. Now we can see that elements at I and j are different. So the element at j is a unique element and we have to add this element to our array. Now how do we add it to our array of unique elements? We will swap the element at jth position with I plus 1th position, that is this position. So we'll swap 2 with 0 and we'll move our I to the next position and j to the next position. Okay, now our I is at this position and j is at this position. Now the element at I and j are same, which means the element at jth position is not unique. So we'll move the j to one position ahead. Now you see that element at I and j are different, which means the element at position j is unique. We have to swap it with next position of I, which means at this point we have to swap this one with this 3 and move I to this position, okay, and j to this position. Now we will see if the element at I and j are same. Yes, they are same, which means element at j is not unique. Move j ahead. Is element at I and j same? No, they are not same, which means we have to swap with I plus 1 position and j. So we'll swap this one with 4 and move this one at this jth position. Okay, now we'll move I to next position, j to next position. J is out of bounds, which means I stays at this position. So as per I's definition, all the element at position I and before it are in increasing order and sorted. Let's check whether they are in sorted order. So first we have 0, then 1, then at next position we have 2, then we have 3, and then we have 4. So basically what this algorithm is doing is it is appending all the unique elements at I plus 1th position, and all the duplicate elements it swaps and push them at back. Okay, so we have these 5 elements as unique elements and we will return I plus 1 as a result, and we don't have to sort because the elements are in the sorted order already. Now we will write this algorithm. So as per algorithm we will need two variables, I as 0 and j at 1 and size as nums dot size. Now until j is less than sz, I will always be less than j, so we don't have to write that, but j has to be less than sz. Now we'll check if nums at I is equal to nums at j, which means the element at position j is not unique and we have to move forward. Else if they are not same, which means we have to append the element at jth position to the right of element at position I. So we'll swap the element at I plus 1th position with an element at jth position, and after swap we will have to increment the j and also I. Okay, so what we can do is we can do this: swap the element at plus I with nums at jth position, and after this operation j will be plus 1, and finally we will return I plus 1 as the unique number of elements. And our test case has been passed. Now we'll see whether it can pass all the test case or not. And our solution has been accepted. That's it.